Welcome back, Algebra 2, to the final video for this class. Congratulations for getting up to this point. In this final video lesson, we're going to be talking about trig equations once again, but this time we're going to be solving trig equations that involve various techniques such as factoring using the quadratic formula, and we're also going to have to recall our Pythagorean identities because we're going to have to rewrite some of these trig equations. So looking at our very first example here, we have 2 cosine squared of theta plus cosine of theta minus 1 equals 0. And what you should notice is this is a equation in quadratic form. Because this is cosine squared, this is cosine of theta, right? And so using that structure, I can let u equal to cosine theta. Right? This is something we did a while ago. And I can rewrite this trig equation as 2u squared plus u minus 1 equals 0. And if you notice, what I end up with is a quadratic equation. From here, we're going to just factor this up. Always make sure you have a 0 on one side, right, when you're using this method. If you factor this carefully, you should get 2u minus 1 and u plus 1. And then from here, what we can do next is you can just set each factor equal to 0 and then solve for u. But the thing we have to remember is that we're not solving for u, we're solving for theta. So what we're going to do now is we're going to go back to the substitution that we made initially and then just rewrite it again in terms of theta. So instead of u, I'll write that at cosine theta. And then from here, what we're doing is we're solving the equation in the interval from 0 to 2 pi. So from here, you got to make sure you know all your angles by now, right? Cosine of what angle gives me 1/2? Well, I'm expecting two angles here, right? One in quadrant 1 and one in quadrant 4. That would be pi over 3 and 5 pi over 3. And then when does cosine of theta equal -1? That would be when theta equals to pi. And that would be my answer for number 1, right? Here we're only finding the solutions in that specific interval. Let's look at another example. So looking at number 2 here, it's a little bit different now because if you notice, I have cosine squared, I have sine squared, and I have sine. But the idea here is we want to do something very similar to what we did at number 1. But before we can do that, we want to rewrite this entire trig equation in terms of the same trig function. So because I see a cosine squared and I see a sine squared and a sine, I'm going to probably write everything in terms of sine. And the way we're going to do that is by using one of our Pythagorean identities. Hopefully this is one that you have memorized by now. And what we're going to do is we're going to solve for cosine squared of theta. And we're going to do that by just subtracting both sides by sine squared of theta. And then what we're going to do is we're going to take cosine squared of theta, and anytime I see a cosine squared of theta, I'm going to replace it with a 1 minus sine squared of theta. So here's my cosine squared of theta. If I make that substitution, I'll get 1 minus sine squared of theta equals 2 sine squared of theta minus sine of theta. And if you notice, I wrote everything in terms of one trig function, okay? And then from here, we want to move everything to one side. So I'm going to add sine squared theta to both sides. And I'm also going to subtract 1 from both sides. The idea is you want to have a 0 on one side. You'll get something like this. And then from here, you can let u equal to sine of theta. And then rewrite the problem. Once again, we end up with a quadratic equation. If you factor this very carefully, you should end up with 2u plus 1, u minus 1. And then just like before, you set each factor equal to 0. And then from here, I'll get u equals to -1/2. U is equal to 1. Now taking that u equals to -1/2, I want to write that in terms of sine, right? So this is really just sine of theta equals to -1/2. Instead of u equals 1, I want to rewrite that as sine of theta equals to 1. And all we're doing is just replacing the u back with sine theta again, right? From here, you got to make sure you remember your angles, right? When does sine of theta equal to -1/2? One of the angles will be in quadrant 3, right? 7 pi over 6. And the last angle will be in quadrant 4, which is 11 pi over 6, right? The reference angle being pi over 6, or 30 degrees. When does sine of theta equal to 1? You can just imagine a unit circle, right? Look at when the y coordinate is 1. And that would be when theta is just pi over 2, right? If you notice, all of our answers are pretty much always in radians now. We kind of stopped working in degrees, so hopefully by now you're also comfortable with radians. But look at how we did number 2 here, right? How we rewrote this all in terms of sine, right? Using our Pythagorean identities. And then from there, we ended up with an equation in quadratic form. So you want to move everything to one side, you want to factor, and in the end, make sure you solve for theta, okay? So at this point, I'm going to try number 3 on your own. It is going to be somewhat similar to number 2, right? The idea is going to be the same. Try this out, and then as usual, pause the video. When you're ready, press play. So first thing I'm going to do here is just distribute the 4. Once again, you notice that you have two different trig functions here. I want to write everything in terms of one trig function. So what I'm going to do is I'm going to use the fact that I know that sine squared of theta is really just 1 minus cosine squared of theta. Again, I got this from the fact that I know that sine squared plus cosine squared equals to 1. Subtracting both sides by cosine squared gives me this identity right here. And so what I'm going to do next is just make that substitution. Keep the left side the same. I see this sine squared. I can replace it with 1 minus cosine squared of theta. And then from here, I'm going to move everything to one side. And if I do that carefully, I'll get something like this. Now from here, I'm going to actually just factor this without making a u substitution. You can keep making the u substitution if you like. But I know if I factor this, I'll get something like this. And then from there, I'll get cosine of theta equals to -3. And then cosine of theta equals to -1. Now, let's solve the second one first. When does cosine of theta equal to -1? Again, imagine your unit circle. Look at all the x coordinates that are -1, right? And that would occur at pi radians. That's only 1. Now, for the first equation, when does cosine of theta equal to -3? Hopefully you didn't put anything there, right? Because if you remember the cosine function, its range is between -1 and 1, right? It could only take on values between -1 and 1, right? Including -1 and 1. And so cosine of theta can never equal -3. It's impossible, right? And so this one really has no solution. And so because of that, this is our only solution, okay? So hopefully you're able to make that substitution, and hopefully you're able to factor it correctly, right? And then from there, you're just using everything we've learned up to now. All right, let's look at another example. So sometimes they get a little bit funky, because if you look at this problem here, you have cosine of theta plus 1 equals sine of theta. You typically want to look for something that's being squared, right? Like you want to see cosine squared or sine squared, because usually that means that you're going to be able to factor it ultimately. But the problem is we don't have anything that's being squared. So what we're going to do here actually is something a little bit different. We're going to square both sides. Which we could do, right? Whatever you do to one side, you can always do to the other. And then we're going to rewrite the left side. Now when you do the left side, please don't just distribute the exponent. If it helps, write it out like this. And then carefully just FOIL it out, right? And if you do, you should get cosine squared of theta plus 2 cosine of theta plus 1. On the right side, you'll get sine squared of theta. And then just like we did before, we're going to rewrite this all in terms of one trig function. So in this case, because I see a cosine squared and I see a cosine, that means I'm going to probably write everything in terms of cosine. So that means I need to do something with the sine squared of theta. And earlier we used the identity, right? That sine squared of theta is really just 1 minus cosine squared of theta. So I'm going to replace the sine squared of theta with that. So rewriting this equation, you should get something like this. Move everything to one side. And you'll get something like this. Now from here, you want to always try to factor, right? In this case, we do have a GCF, the GCF being 2 cosine theta. So I'm going to factor out the 2 cosine theta. And if I do, I'll be left with cosine of theta plus 1. And again, if you're not sure how I got this, you can just distribute the 2 cosine of theta. And you got to make sure you get back to the line we had before. And it does work out. Now from here, I can set each factor equal to 0. And then solving for cosine of theta, I'll get 0 and -1. And then from here, just solving this out, right? What makes cosine equal to 0? That'll be pi over 2, 3 pi over 2. Again, we're only looking at angles between 0 and 2 pi because those are the directions. And then when does cosine of theta equal -1? Pi. Now this is where to be very careful though, because if you stop here, you'd be incorrect. What we need to do next is we need to check for extraneous solutions. I always think of extraneous solutions as like extra solutions that appear, but they're not actually solutions, right? It just seems like they are. And so the reason why we have to check for extraneous solutions, by the way, is because of the fact that we took the square of both sides. And when that happens, you actually end up usually with more solutions than the original problem. And so because of that, we always have to check for extraneous solutions. And so you always want to make sure you check the original equation. The original equation was cosine of theta plus 1 equals to sine of theta. And then from there, we're just going to check our answers. And this is something similar to what we did in the very first example in the last video, right? So starting with theta equals to pi over 2, I'm just going to plug it in. I'll get cosine of pi over 2 plus 1 equals to sine of pi over 2. Again, we have a question mark here, right? Do we get a true equation? Cosine of pi over 2 is just 0. 0 plus 1 equals 1. This is definitely true. I'm going to check 3 pi over 2 next. Again, we're just going to plug it into the original equation. We have another question mark. Cosine of 3 pi over 2 is 0, right? So we just have 0 plus 1 equals. Now sine of 3 pi over 2 is negative 1. That is not equal. So this is not a solution, right? We have an extraneous solution. Lastly, you want to check theta equals to pi. Cosine of pi plus 1 equals to sine of pi. Cosine of pi is negative 1. Sine of pi is just 0. 0 equals to 0, and that is a solution. So in this case, we only end up with 2 solutions, not 3. So whenever you square both sides, always check for extraneous solutions, okay? Let's look at one more example together before I let you try one on your own. So looking at number 5 here, we have tangent of theta equals to cotangent of theta. I'm going to show you a couple of other techniques that we can use when we solve trig equations, right? So far we did factoring. We used our Pythagorean identities to rewrite it as a trig equation. Here, we're going to actually just rewrite everything in terms of the same trig function. And I'll show you how we can do that. So tangent of theta here is equal to, now cotangent of theta is just 1 over tangent of theta. So a lot of times, if you can rewrite the entire equation in terms of one trig function, I would usually do that. And then from here, what I can do next is I can just multiply both sides by tangent of theta. And the reason why I did that is because this will just cancel out, we'll be left with 1. On the left side, I'm left with tangent squared of theta. Now from here, I can take the square root of both sides, because again, you want to isolate the tangent function, and you want it to be a power of 1. Now when I square root both sides here, I want to make sure I put a plus or minus. So what that tells me then is I'm really solving 2 equations here. Tangent of theta equals to 1, tangent of theta equals to negative 1. And again, we're only finding solutions between 0 and 2 pi. So what the nice thing about tangent is that it has period of pi. So I only need to find the solution in the first 2 intervals, right, between 0 and pi. That would give me pi over 4. And then once I know that, I can just simply add pi to it, and I'll get my second solution. So if I just take pi over 4 and add pi to it, I'll get 5 pi over 4. So these are 2 values that make tangent of theta equal to 1. For tangent of theta equals to negative 1, I just need to find the one angle between 0 and pi. This will give me 3 pi over 4. Right, quadrant 2 is when tangent's negative. And then just like we did before, I can always just add pi to this because tangent has a period of pi. And if I do, I'll get 7 pi over 4, and that would be the angle in quadrant 4. So here we have 4 solutions to this equation, right? So you want to make sure you know all your identities because you are going to have to get creative when it comes to rewriting these trig equations and knowing the different techniques that are out there. So at this point, I'll let you try number 6 on your own. Think about all that we've learned so far and try this out and see what you get. What I'm going to do is I'm going to subtract both sides by cosine of theta. I'll be left with sine of theta equals to negative cosine of theta. And then I'm going to divide both sides by cosine of theta. If I do that, on the right side, I'm left with negative 1, right? On the left side, I'm left with tangent of theta. You see how I rewrote this in terms of one trig function? From here, if I solve this out, this is something we just solved actually in the previous problem, right? So I can just write the answers as 3 pi over 4 and 7 pi over 4. This is one way to do it. Now, if you were to square both sides, this is what might have happened. From here, you would just multiply everything out. And then cosine squared plus sine squared is just 1, right? So you'll be left with 2 cosine theta sine theta plus 1 equals 0. And then from here, it just gets kind of confusing. And the problem is we don't know how to go from here is because we haven't learned our double angle identities and things like that. That was like 7.456, somewhere along there. So because of that, we don't know enough to continue solving it in this way. And so what we want to do here is just rewrite everything in terms of one trig equation. So guys, review these techniques, right? There are quite a few different techniques, but they're all kind of similar. So what you notice at the end is that when you're solving these kind of problems, you want to rewrite everything in terms of the same trig function. And then from there, you're typically going to factor. You can also use a quadratic formula when it's not factorable. But for the examples that we did today, they were all factorable, which means that you probably don't need a calculator when you're solving these. So guys, this is the final lesson. Congratulations once again to getting to this point. I hope you guys finish off strong. Continue working hard, guys. Keep reviewing this because you will see this again a lot in the next couple years, right? These concepts, these trig equations, these trig identities, very, very important stuff, guys. So have a wonderful rest of your day, and I hope you guys have a wonderful summer.